Right. All right, so Sky, give me an example of a vector. O to where?
What to be?
Okay. Right, so vector that starts. So warning, guys, you all are going to see trigonometry. I just putting that out there. All right. But it's not much trigonometry, to be honest. It's not much. It's really not much. Right? You'll be fine. I promise. Right. And Sky, this vector you told me about, right? Um, Tell me what it is. So let me just say we have a vector O to B. O to B, you want that to be what vector? Let me just say we want the vector to be in the first quadrant. Give me a value. So remember, Sky is a horizontal movement followed by a vertical movement. So I want OB to be somewhere over here. So give me a horizontal movement and a vertical movement. We're just sketching here.
Mm, so 6'5".
Should I say 6, 7? We're gonna use 6, 7. All right. So you have two things you need to be able to do. You need to be able to find the angle between a vector and the x-axis, and you need to be able to find the magnitude of a vector. So that's the two things you need to do. So let me just write that down over here. So the two things we're going to cover is finding angle between position vector. That's one thing we have to do. And the other thing we're going to look at is finding the magnitude. Sky, how about you with trigonometry?
So, okay, I
Okay, well,
think.
word. It's really simple, and there's just two formulas you need to remember. So for the first one, the formula that you need to remember is theta. Theta is the angle. Theta would just be equal to tan inverse, right, of the y component all over the x component. That's literally it. It's very simple. And if you want to find the magnitude of a vector, right? So you want to find the magnitude of a vector, it's just equal to the square root of, right? Square root of x squared plus y squared. All right. Let me know if you're okay with everything so far. So that's what we're going to look at today. Find an angle between position vector and x-axis. And the formula for that is tan inverse y over x, right? And you need to find the magnitude of a vector, right? Which is given by the square root of x squared plus y squared. Let me do an actual example, and you'll see where we get those formulas from. Okay? Sky, do you remember how to do trig ratios? Sine, cos, and tan? Yeah or no? Tell me, Sky, be honest. Okay, Mira. Mira, what about you? Do you remember sine, cos, and tan? Why everybody so quiet for?
Could you repeat, please?
Yeah. Do you remember how to find the angle using sine, cosine, tan?
No, I'm being very honest too.
Okay. Well, that's good. Right. So Mira, we have a vector here, O to B. So do you understand? You're starting from the origin, as well as our position vector. You move 6 spaces to the right and then 7 up. Understand? So just
Good.
great.
Yeah.
So the two things we need to figure out is what is the length from here to here? We call that the magnitude. And the other thing we need to figure out is the angle it forms between the x-axis and the vector. Understand?
Yeah.
Do you at least remember Pythagoras theorem?
Partially.
Partially, okay. I love in the honesty. I don't mean in a sarcastic way. If all you don't understand something, better always tell them all you don't understand. All right. So Mira, we want to find for this angle. Yeah, this angle over here.
Uh-huh.
As the first thing we want to do. We're gonna call that theta. Right. Tell me, Mira,
Mm-hmm.
for this triangle, would
Yeah.
I be able to figure out this length over there? That length over there.
Yeah.
What would that length over there be?
That would be 7.
That would be 7. Could you tell me what this dimension would be?
7. I mean 6.
6. Now, from trigonometry, if this is the angle we are considering, then this side, I would call this side the opposite. Think you know why?
Because it's on the other side of the angle.
Exactly right, because it's opposite to it, right? So I would call this side the opposite. I would call that the opposite. And tell me, Mira, this side is right next to the angle, is it not?
Yeah.
So what's another word for right next to? So that's what A. E.
My brain telling me to say across, but that don't make sense.
Nah, that don't make sense.
Adjacent.
And yes, Desran, adjacent, adjacent. Mira, adjacent is the word you're looking for, right? So adjacent. I'll write it out. This is opposite. Right, this is adjacent. Okay, and Mira, last one. What do you call the longest line in a triangle? That's what H. H.
Hypotenuse?
Remember that one? Nice. Hypotenuse. I cannot run out of space. Okay, and do you understand that we know what the length of the opposite is? The length for the opposite is 7, and the length for the adjacent is 6. Yeah or no?
Yes.
And we want to find an angle, right?
Yep.
Great. So what two pieces of information do I have?
You have the opposite, the length of the opposite angle and the adjacent. So you
Right.
um
Oh,
you could use, is it tan? And
yes,
you could
tan.
use that in the equation.
Right? Why? Why is that? Because the three equations, the three trig identities you should know is sine, cos, and tan, right? So, ka, to. It kind of sounds like
Katoa.
soccer too. It kind of sounds like soccer too, but you never hear that from me. All right? So, katoa. Great. So the first one represents sine. It says sine theta is equal to O over H. The second one says cos theta is equal to A over H. And do you all think you could figure out what the third one means? Tan theta is equal to what?
Opposite over adjacent.
Right, man, Sky, you know the thing. You know the thing. Triggs boss right here. Right? So 2r would just be over a. Now, in any equation in maths, you want to end up with one unknown. Sky, and when we have one unknown, we could solve for it.
Yes, sir.
So if I were to use sine, I don't know what the angle is. I do know what the opposite is, but I don't know what the hypotenuse is. How much unknowns I have there?
So two.
Nice. Most are a little older, right? I will just say this. One is enough. Two is nah. One is enough. I'll get what I mean. Great. I'm gonna move on. Right? Sky, if you decided to use cos, give me 1 second. Speaking of one, D1 is calling me. All right. Right. Let me continue. Right. So Sky, if I decide to use cos, right? If I decide to use cos, do I know what the angle is?
Um, yes, sir. I
No.
mean, no.
No. Wait, what? Yes. Will you see the angle? Tell me yes. We don't know angle, right? That's our unknown. Do we have A?
Yes, sir.
We have A. Do we have H?
No, sir.
How much unknowns we have there?
Two.
That's problem, right? That's real problems. What about tan? Do we have the angle?
No, sir.
Do we have the opposite?
Yes, sir.
Do we have the adjacent?
Yes, sir.
Right. How much unknowns we have?
One.
Right. So that's why we're going to use tan, right? So I would say tan theta is equal to O over A. That's the one I'm going to use. Why? Because I have one unknown. Mira, if I use tan theta, what's the only thing I don't know here? Tell me, Mira.
You don't know the angle.
Right. But in all the others, you didn't know what the angle was as well as one other side. Right? So I guess I guess I'll get in some practice for trigs as well. That's great. So Mira, let's continue. So I will need to find what theta is. So I need to do the opposite of the tan function. You know what's the opposite of tan? Mira, and you was there when we was doing functions, yeah or no? You had come to the classes when I did functions.
I can't remember that. I don't think so.
You don't be in the form for classes.
Nah, I was in the phone book.
You could well since you're writing back, you have free access to the form for classes, right?
Yeah, well, I gotta start joining now. No.
Yeah. Because check this, somebody that is being informed for class, right? Ria, if I have f of x, what would I call the inverse function for f of x? Ria,
Yes, sir.
what would I call the inverse function of f of x?
Um, F inverse 1.
F
No.
inverse x.
F.
F inverse x. So what do you think the inverse
Yeah.
function for tan will be? It would just be tan what?
Tan inverse.
Right, tan inverse, right? It's that simple. It that simple. So here what? To find for theta, you'd need to do the opposite of tan, which is tan inverse. So you'll have to find tan inverse of O over A. Now get this, guys. Get this. I want you all to figure out the pattern. O, in this case, corresponds to the what component? The horizontal component or the vertical component? Somebody tell me.
Vertical.
Right. And what do I talk when we talk about vertical, we're talking about X or Y?
Y.
Right. So we're gonna replace O with Y. And A. A corresponds to what component of the vector? It's horizontal component or vertical component?
Horizontal. So in that
Right.
case, it's X.
Right. Do we all understand how the formula came about? That's how they came up with the formula, that tan inverse. If you want to find the angle, it's tan inverse y over x. Because for any vector, I feel like some people are still confused. So Mira, nth and for any position vector, right? In this example, the position vector was O to B. And could you tell me what O to B was in column vector form? Tell me, Mira. So do you remember what column vector form is?
Um, is it O to 6 to B? Does that make sense?
No, it's just 6, 7. A column vector is made up of a x value and a y value.
I think about the direction.
Right. Check this. You're starting from the origin, which is 0, 0. Okay, so from 0, right? 0, you add 0. Then you're going to move 6 to the right, and then you're going to move 7 up. So the x component is 6, and then the y component is 7. Understand? So Mira,
Yeah.
all vectors consist of a what movement first? What movement first?
Horizontal and then vertical.
Right. Great. So I need you to understand that for a vector v, the column vector form would be x, y. Understand? Yeah? And you saw for yourself. If I have a vector O to B, right? Then and it was 6, 7, the what component would that be 6? What component would that be 6? Horizontal or vertical?
Horizontal.
Right? So horizontal is 6 and the vertical is
Vertical is 7.
right. So you see how we just end up being y over x?
Yeah.
So for any vector, if you want to find the angle between the x-axis and the y-axis, you're just gonna say tan inverse y over x. There's really not much to it. It's very simple in the sense that you just have to apply the formula and done. Right? Yx. So for this question, the angle would just simply be tan inverse of y over x. Could somebody tell me what the y component here would be? I mean, you could look at the graph too, right? What's the y component? So Mira, if I want to find the angle between OB and the x-axis, I have to put the y value over the x value. So what is the y value here?
The Y value is 7
All right,
and
so
the X value.
great. And you can see it for yourself on the table, I mean on the graph, right? Watch. Tan theta, so tan theta is O over A. Isn't O 7 and isn't A 6?
Yeah.
Same thing, right?
Oh, okay. I get it now.
So I'm gonna go it over one more time just for anybody that might be confused. So Sky, you there?
Yes, sir.
Right, so Sky, can we both agree that any vector would have a horizontal component and then a vertical component?
Yes, sir.
So you move either to the left or right, and then you move either up or down. Simple. That's the premise of a vector. Great. So we want to find the angle between the vector and the x-axis. So to do that, you will need to know the horizontal component and the vertical component. It just so happens that all the time, the horizontal component will be the adjacent, and the vertical component will be the what, Sky? The vertical component will be the what?
So you can repeat. Answer.
I said that once you have a position vector, the horizontal component would be the adjacent, and the vertical component would be the
The opposite.
right. So you can come up with this generalized formula. If you want to find the angle, it's just simply tan inverse of y over x. And if I use our formula, y is 7, so I get 7, x is 6, so 7 over 6. Understand?
Yes, sir.
But if you do it like this, you get the same answer. Watch this, right, Sky? So we have tan theta is over A, right? So we got theta is tan inverse O over A. From the graph, what is O? What is O?
7,
What is A?
6.
Right, the same thing, right? So the formula we came up with works for all position vectors, all, right? And it finds the angle between the vector and the x-axis. So we understand that?
Yes, sir.
Great. So let me just fix up that note and I'll give you all an example. I already have an example. Kadisha, if you're confused, tell me. I will go it over in detail. If you're confused, that's not a problem.
Yes, sir. I am a bit confused.
Okay, no problem. You remember tricks? Trigonometry. Let me know if you remember that.
No, sir. That was years ago.
Years ago? All right.
Yes.
So I'm saying that if you want to find, wait, so first things first, and you understand that a vector would just be a horizontal movement followed by a vertical movement to take it to a point.
Yeah.
Yeah. So this vector over here, O to B, isn't that just really 6 to the right and then 7 up?
Yeah.
You sure you understand that?
Mm-hmm.
Great. So I said O to B was 6, 6, 7, right? Why? Because if I start at O and I want to go to B, I need to move 6 to the right and then 7 up. So 6, 7. Could you tell me what the horizontal components would be?
Um, 6.
Mm-hmm.
Um, I don't know. I don't want to be wrong.
So the horizontal component is 6. And what is the vertical
Right?
component?
7.
That's all, right?
Yeah.
Great. Happy you understand that. Next thing you need to remember, there are 3 trig ratios, sine, cos, and tan. We are using tan because, check this. We have, okay, so if you label any triangle, and this is the angle, I would call this side the opposite because it's opposite to the angle. I'd call this side the adjacent because it's right next to the angle. And I'll call this side the hypotenuse. The slant line is always the hypotenuse, right? So
Okay.
if you look closely, we have the opposite, we have the adjacent. And if you look at the formula has opposite and it has adjacent. And I know what the opposite and the adjacent is.
Yeah.
So what's the only thing I'm missing here then? The angle, right? Theta is the angle. Theta is
Yeah.
the angle, right? And tan is a function. So the only thing I'm missing is theta. So I have one unknown, which is good. Like I said, Kadisha, you don't want 2 unknowns in your life. That's pressure. One is enough. Yeah. The
Yeah.
same thing applies for maths and in real life. All right. So I didn't use sine and cos because I had 2 unknowns, right? If I decided to use sine, right? Watch. I don't know what the angle is, that's one unknown. And I don't know what the hypotenuse is, that's 2 unknowns. The same thing over here. I don't know what this is and I don't know what this is. Anytime you have 2 things you don't know, pressure. All right, Kadisha? You want to end up in a position where you have one unknown. All right? So we decide to use tan. So we're using tan theta is over A. Following?
Mm-hmm.
So we're using tan. To find for the angle now, I will have to say tan inverse of O over A. Right? O is the opposite, A is the adjacent. Now, it just so happens that every single time, the opposite would correspond to what component? Horizontal or vertical?
Um, vertical.
Right, vertical. So I said that the opposite would be the y component, right? Because it's vertical. And the x would correspond to the adjacent, right? Because look, the adjacent is the what component? Horizontal or vertical?
Vertical.
Great. So let me know if you understand that. So this is this
Yes,
is
sir.
this is the formula we came up with. If you want to find the angle between any vector and the x-axis, you would say tan inverse of the y value over the x value. Let me know if you understand that.
Repeat it.
So this is the formula you're going to use. So
Right.
if you're given a vector and you want to find the angle between the vector, so you understand in this question, the vector is O to B over here, O to B.
Right. Mm-hmm.
I- If I want to find the angle between that and the x-axis, which is this,
Mm-hmm.
I would say theta is just tan inverse of the y component over the x component. That's something you can plug into your calculator.
Okay.
And the y component would be this, and the x component would be that.
The adjacent. Okay.
Yes. Right? And when you're given a question, it'll look like this. So O to B is 6, 7. Right? Anytime you're given a vector, it's always the horizontal movement first, then the vertical movement. So it's just going to be tan inverse of the vertical over the horizontal. If you understand?
Mm-hmm.
So a way to, you know how to plug that into your calculator?
Yeah, but I don't have my calculator right now.
Oh, shucks.
Yeah, not home.
All right. Well, somebody that does have a calculator, let me know what you're getting for tan inverse 7 over 6.
So let's type in again. I'm retrieving if I carry my mind
All right.
on the Casio.
Let me show you guys. I can't see your calculator at. Okay, here it is. Okay, if you want to put in that, you're going to press Shift, Tan, Shift, Tan. Then you're going to press the fraction button. You're going to put 7 on top. You're going to press the arrow to the right. And in the denominator, you're going to put 6. You're going to press the right arrow once more. You're going to close off the brackets and then press equal. And you should get 49.3987, etc., etc. Let's run, just confirm that.
Yeah, I got that.
Okay, nice. Right?
For me.
Are you all getting that?
Yes, sir.
Yes, sir.
Okay, good. Right? And if you actually look at it, it kind of makes sense, right? Obviously, we didn't draw the best diagram here, but you could kind of see that the angle, and we could clearly see that the angle is like less than 90, but like a little more than 9, a little more than 45. Look at this. If this is 90, if this is 90, right? Then this would be like this would be 45. I didn't draw it perfectly, but the angle here is like a little more than 45. As you saw, it was 49.398. Right? So there's run. If I round that off to 2 decimal places, what am I going to get? So I got the answer I got was 49.398. It's right on the full thing. 49.39870. All right, that's round. So if I want to round that off to 2 decimal places, we need to figure out how I'm going to do that. So that's round. What's the second decimal place? That's round.
Yeah.
What's the second decimal place?
It's like one decimal places. The common place will be
So we're gonna
um
start counting after the decimal. So 3 will be the first decimal place. 9 will be
49.40.
49.40?
Yeah.
Yes. Because if this is the second decimal, the number after 9 is 8, so you would add 1 to 9, but that would come like you're adding 1 to 3, so that'll be 0.40. Understand?
Yeah.
Nice. Don't worry, I'll give you all a question to do. It's very, very simple, I promise. Right, so 49.4. Right, so Mira, does it look like it makes sense? If you look at the diagram, does the angle look like 49? I mean, I didn't draw it perfectly, right? But does it look close enough?
Yeah, you could say so.
Yeah. Right. So let me just take this diagram. So we just now found for theta. So theta, which is the angle between the x-axis and the vector, is 49.40 degrees. Right, so copy down this example. Right, so copy that down, guys. Right, and while you're doing that, I'll get a question for you all. Right, so as soon as you have everything copied down, let me know, right, guys? Let me know. All right, does everybody have it copied down?
Yeah.
Yeah, okay. All right, we're gonna move on to an example now. So, a question. Right, before I move on, there's one case I need to show you all. One case. So I'll do one more example quickly, very, very quickly, and then move on. Right. So the example 2. Right. So Sky, let's observe what happens when we have a vector that is not in the first quadrant. By the way, in the Cartesian plane, there's 4 quadrants, right?
Yes,
So
sir.
let me show you what's gonna happen. So you would have noticed that 6 and 7 were positive values, right? Yeah.
Yes, sir.
Can you have negative length for a triangle?
Yes, sir.
Yes. So on your ruler, does it say negative 5 centimeters?
Wait, no.
I catch you lacking there. You just not tell me negative length exists. Wait. I want to see if I catch you off guard another time. I'm gonna ask you if the earth is flat. Uh, if you say yeah, well, that's crazy. All right. So give me another vector, but this time incorporate some negative numbers into it. So let me just call this vector O to C. All right. Give me another vector, but this time put a negative number somewhere there.
Mm, so -5, 7.
So that means I'm going to start from the origin. I'm going to move. How am I going to move? So -5, 7. How would I move here?
Left.
Say that again.
To the left.
How much space is to the left?
Well, 5 spaces. Say that.
All right, 5 spaces to the left. Okay. All right, and then what next?
7 spaces on the y-axis. Okay.
And that would take me to what point?
Um, -5, 7.
Well, look at the vector. What does the vector say? What does that vector say? You're starting off where, and it's carrying you to where?
O to C.
Yeah, so you start at O, and you're gonna go to
C.
yes. So this final point you reach, well, what are we gonna call that point?
Point C.
Yeah, C, because you reach C, right? So O to C. To go from O to C, now here's where a lot of students would crash out. Am I going to say that I move -5? Did I move -5 or did I move 5? But just to the left.
So you move 5 spaces to the left.
Right, I move 5 spaces to the left. Right? So I'm really gonna put 5 over here. I'm gonna if that confusing you. I'm going to say that this dimension here is 5. Is that confusing you? If I say that's 5 spaces, would that confuse you?
No, sir.
And this would be what?
7 spaces.
Right. So remember, wasn't the formula theta is equal to tan inverse of y over x?
Yes, sir.
Right. It was tan inverse of y over x. Now, y and x needs to be positive. I'll make a note about that. Y and x needs to be positive. We'll see what will happen shortly if you don't do that. All right, so Sky, tan inverse of y over x. So tell me, what's the y component? Y component would mean how much did you move vertically? How much spaces did you move vertically?
7 spaces, sir.
And how much spaces did you move horizontally?
5 spaces.
Right, so find tan inverse of 7 over 5. Wait, before we do anything, right, Sky, the angle here, the angle, theta. Give me like a guesstimate value, like a guess value.
Mm, so that look like 60.
Looking close, looking like more than 45 for sure. And
And like,
okay, put tan inverse 7/5 into your calculator and let me know what you're getting. What are you getting?
I got 54.46.
All right. So we were close, right? We were close. Close, right? Yeah? Do you think our guess was close? We say 60.
Yeah,
Right? So if you run out of two decimal places, it's gonna be 54.46. But you're probably curious as to know what would happen if you used n- um if you use -5 for accent. I mean, what I'm saying, you're probably wondering what would happen if instead of oh no, I said the correct thing. You're probably wondering what would happen if I use -5 instead of 5 here. Probably, ain't?
yes,
Are you see what happened? What happened in there?
I got negative.
Yeah. You get a negative angle.
Yeah,
So do you know what a negative angle would mean?
yes,
Okay, a negative angle would just mean that it's going in the opposite direction. Like, let me show you specifically what's happening here. So this would be positive 54. If I get a negative angle, this is what it would mean. It would mean this. That's what it would mean.
Oh, okay,
So
okay.
anytime you see a negative by an angle, it just means you're going in the opposite direction. So until you understand an angle could move either clockwise or anti-clockwise.
Yes,
Yeah, well, if an angle is negative, it just means you're gonna move in a different direction. Different direction. Yeah. Right. So I'll make a note about this somewhere. Right.
So I understand what you're doing and I'm following, but I have a sharp calculator and I kind of crashing out.
Okay. Right. So if you have a sharp, um, I think it should be the same thing. You might have to press shift. You have shift in the sharp calculator or second function. Yeah, second function.
Yeah.
Okay, wait. Let me just pull up a sharp calculator. Right. You want to press second function tan. You see tan inverse come up?
Yes, thank you. It was saying error for a moment.
Oh, well, you get through there, right?
Yeah, I got you.
Okay, say no more. Right, so I'll put this note in the first example as well. Right, so you all could go ahead and copy this example. Now, again, look at what I'm saying. Mirror, mirror. Notice that 5 and 7, right? Notice I didn't use -5. And why is that? If we are considering the lengths for a triangle, can we have a negative length? Mirror, can we have a negative length? Does your ruler have -5 centimeters? Adding negatives in a on a ruler. Give me a runner here and yeah, I don't know what's going on. Right, Adetola, long time I didn't hear from you, right? Long time I didn't hear from you. Let me know if you're there.
Yeah.
Right, so Adetola, does your ruler have negative 5 centimeters on it? Does your ruler measure?
Repeat?
Does your ruler have negative numbers anywhere on it?
No.
No. Can length be negative?
No, I don't think so.
No, length can't be negative. You think you can measure minus 5 meters?
No.
No. Right? So if we are measuring length, right? If we're talking about the vertical length over the horizontal length, both of them had to be positive. So added to you'd have probably noticed that O to C was minus 5, 7. Right? Now I understand what you're saying. In the column vector form, the first value is y and the second value is x. Yeah?
No.
Right. But what I'm saying is it has to be positive. Like the y and x value, they need to be positive. So you wouldn't use y as minus 5. Wait, why put y first? Make a mistake here. Yeah, x. Right. That should make a lot more sense. Right? So yeah, Aletola. I would not use negative 5 for x. Think of it like this. Look at this vector, right? The vector was O to C. So Adetola, that means you're starting from the origin, and from the origin, you're going to move how much spaces to the left? If you want to reach C, how would you reach C? Adetola, right?
I was talking, I was muted. Price spaces.
You'd move 5 spaces to the left, and then how much spaces up?
7.
So ain't you moving? If we're talking about that aspect, we're talking about the amount of spaces you moved. Wouldn't that have to be positive?
Yeah.
Yeah. So we said the y value was 7 all over the x value, which was minus 5, but we need to consider the absolute value of it, which is just 5, right? So 7 over 5. So theta is 54.46. Let me know if you understand this.
Yeah, I understand.
Okay, great. Let me give you all a question. All right, Desron. Let me know if you understand everything.
Yeah, yeah.
Okay,
I got
good.
for now.
Find the angle theta between vector O to J and all right, so you all could go on and give that a shot. All right, guys, are we getting through?
Yeah.
All right, guys, to avoid confusion, I'm going to adjust the formula to be a little more precise, right? Because some of you all might use the formula and you might use the negative value. I don't want that to happen. So let me just make the formula a bit more precise. I'll explain what I'm adding in, right? All that means, that just means the absolute value. That's all it means, right? So you'll make the respective changes. Because you need to use the positive value. If you don't use the positive value, you'll get a weird answer. So everywhere you had copied down tan inverse of y over x, I want you to put these two lines at the start and the finish. That just basically means you're going to take the absolute value. So if the value is -5, you're not going to use -5. You're going to use +5. Right? That's the proper thing you're supposed to do. Right? At the CSEC level, they typically won't penalize you if you write it like that, but that's not the 100% proper thing to do. Right? And I want to give away the proper thing. So, great. Nice. So, Mira, instead of writing tan inverse of y over x, write tan inverse over the absolute value of y over the absolute value of x. That's what that symbol means, the absolute value or the magnitude. Right, so as soon as you all have part one, let me know what you got. Again, x and y needs to be positive, right? Because they correspond to length. All right, Desron, you there?
Yeah.
All right, Desron. I seen some things we had to work on with regards to your working. So in the second one,
Mm.
by the way, you don't have to write tan in capital letters, eh? Typically, we
Mm.
only write the T in as a capital letter, so capital T-A-N.
Mm.
Then I see you leave out the one by the minus, put -1 and
Oh, sorry. Yeah.
get rid of that equal sign because it's tan inverse, right? And is 7 over 2.
Okay.
And in the third line, it's supposed to put 74.05 degrees. You're missing the degrees sign. I mean degrees.
Okay. Fine.
So just fix up and you'll get full marks. Right, so Mira, I'm waiting on working from you. Kadisha, I wonder if you're there.
Yes, sir.
All right, so Kadisha, yeah, let me know if you understand this.
Yeah, I understand.
Okay, good. So I'm waiting on an answer from you, right, Kadisha?
Yes, sir, I understand. Not to explain it back to you, like to explain what I understand, but I understand.
Okay. No, I mean like I'll wait on an answer from you. Like I give a question, I'm waiting to see when you come up.
Oh, sorry, I didn't hear the question. I was talking to my daughter.
Oh, that's okay. Right? Perseus.
Mm-hmm.
Perseus, one more
No,
thing.
no, no, still, I make a mistake. I just make a mistake with the number. I'll change it.
Yeah, because I see you put 5 over 2.
Yes, I think I need to go and check my eyes. That's my bad.
Oh, you mean this question here? No, I didn't do this.
All right.
Because I'm at home, so I don't have my calculator.
All right. So Kadisha, let me run through the question, right? So first things first, Kadisha. This is an example of a what kind of vector? It starts at the origin. So kind of vector is that? Starts with P.
It starts with P.
Yeah. It kind of sounds like pose. Pose.
Johnson.
All right,
Okay.
position vector, right? Any vector
Okay.
that starts from the origin, like it has O in it, starts from the origin. So, Kadisha, just to give you a recap, a vector is made up of a horizontal component and a vertical component.
Right.
So, just again to recap, the x component is always given first and then followed by the y component. So, if we're talking about the x component, it means you're either moving left or right, depends on the sign. If we're talking about the y component, we're talking about up or down, but again, it depends on the sign. So if we have -2 corresponding to x, that means starting from the origin, by the way, if you're confused, it says O to J, right? If it says O to J, that means you're starting from where and going to where. If it's O to J,
It's starting from the the bottom going to the
right? In the name, check it out. It's in the name. So check the arrow.
going to the right. Yeah. Okay.
So they're going from O to what? O to what point?
From
So
O to X.
O to J.
O to J, right? But to the right.
No. Hmm.
To the left because it's minus.
Yeah. Right? But
Okay.
wait, I just want you to understand this. Like this, what this means is you're starting from O and wherever you land up at, you'd call that point G because you're going from O to
Oh,
G.
because I was looking for where J is, but
Don't worry, we're gonna end up at G following this instruction. So we're gonna start off at O and
okay, right.
the instruction is you're gonna move
So
-2
you're moving
x.
to the left.
Right? How much space is to the left?
2.
Right? Nice. And then you're going to move what?
Um, to the
Nah,
left again to -7.
nah, take your time. So
Or to the right.
no, not to the right. Okay, so take your time, right? So the first
Oh, sorry, you're going up. Sorry, because
nah,
Y is
it's not going up. Not going up. It's a negative value for y. It's a negative value for y. That means you're going down.
so
So
wait. Down is negative. Okay, and then up will be positive. All
yes,
right.
right? I'll call this -7. So if I were to follow those instructions, I would move 2 spaces to the left and then 7
And
spaces down.
down. Okay, yeah.
And that would carry me to G. So that would be O to G.
Oh, okay. So sometimes they don't give you like they won't put like exactly O to J, but you have to figure it out as you go along.
You have to figure out where
Depending
G.
on if you're going where negative, positive, up or down, whatever.
Mm-hmm.
Okay.
So let me know if you're following.
Yeah, so I'm following. I was just looking for the G in the
That's okay. I mean, the whole point of the vector is to carry it to somewhere. It's carrying you somewhere. Vectors is just directions, you know. That's all. Vectors is just directions. It's just directing you to go from one point to another point. That's all.
Okay.
Right? So you understand that I would call this point over here G, right?
J, and then the beginning, the top is O.
Right. So you start
Yeah.
from O and you end up at G. Right? And to go from O to G, you had to move how much spaces to the left?
2,
And then how much spaces down?
7.
Right. So here what I was saying, right? And you clearly see and have an angle between that vector there. So this is the vector, right? This is the vector.
Mm-hmm.
I did have an angle between that and the x-axis.
Yeah.
Right. So the objective here is to find for that angle. So to find for that angle is the formula you're going to use. So to find for the angle, theta would just be equal to tan inverse all over the absolute value of y all over the absolute value of x. So, Kadisha, if that confusing you, don't get confused. All the absolute value means is a positive value, right? So check this. You see how we have like you see for the if we're talking about the y value, isn't the y value like okay, let me look at the actual question. If you look at the actual question, what's the y value? Positive or negative?
But -7.
-7. But as you saw, the distance was actually 7. The length was actually +7. And you see in that
Yeah.
the negative just tells you the direction. But it just tells you the direction. If I tell you,
Mm-hmm.
like if I said if you started off from here, right, and I told you -2, does that mean the length is -2, or does that mean the length is 2 but the direction is left?
It means that the length is 2.
Right, but the direction is to the left. Great. So I want you to understand all this symbol means, like the two things on either end, it just means the positive value, right? So you see how we have -7?
Mm-hmm.
The absolute value of -7 is just 7. So on the inside, we're going to write +7, right? And instead of writing -2, we're going to write +2 and plug that into the calculator and you'll get your answer. Understand?
Yeah.
And this you can do this for all the questions, right?
Or could you say a negative and a negative equals a positive?
Um,
Or does that apply to this
no, in
or
this
is that
in,
simply because the direction is minus and then the length will be 7 and that then just that's it?
exactly because we are considering the length, not the direction. In the calculations, we're considering the length and the
Or
length
not the
is positive.
or not the sign.
Nah, just the positive, not the sign.
Okay.
Right? And that is what this symbol here means. You see how we have like two lines on either end?
Mm-hmm.
That's what it means. If I have the absolute value of -7, that would mean 7. Yeah.
Okay.
Right? But simply put, it's just tan inverse of y over x, but y and x had to be positive. That's simply it. So y over x, but this had to be positive. So 7, this had to be positive 2. Find tan inverse of that, get your answer. All right. So let me find the answer in the calculator. But before we find the answer, right, Kilisha, I want you to kind of estimate what does a vector look like? How much degrees?
Um you mean that angle in the middle there?
Yeah, the angle in the middle there.
Like average?
Yeah, average.
Um Probably about 40,
Nah. This would be 90. This
90.
no, watch. This would be 90 degrees. Watch. This would be 90. Half of 90 would be 40.
Right.
So that's 45. So this had to be like more than 45 because it's quite over here. This would be 45 degrees. So this looking like like close to 60.
60. Okay.
Let me see. Tan inverse of 7 over 2. We get 74. That makes sense. Right? Let me know if you're confused.
That's right. I'm so confused.
All right. Desron, you got that right?
Yeah, yeah.
Nice. And Priscilla, you got that as well. Great. Mira, I didn't get anything from you. Mira. Ways by catching Mira lacking, boy. Ways. All right. Okay. So do we understand how to find the angle between a vector and the x-axis? It's just simply y over x, but y and x had to be positive. Let me know if you're okay with that.
Yes, sir. I understand it, and I didn't get answer simply because my calculator wasn't cooperating.
Ah, I see. But you
So
understand, like fully.
yeah, how you again? Tan inverse again on the sharp calculator.
You're gonna press second function, tan.
Second function.
Tan.
Oh, okay. Thanks.
Problem. Right? So guys, the final formula, anytime they ask you to find for theta, is just simply tan inverse, right? The absolute value for y. So whatever y is, the positive value of it, all over the absolute value of x. So whatever the value for x is, you just find it, just put positive instead of negative. That's all. And that's all. That's it. So I'm gonna give all that question and I want to tell me the answer in 1 minute. What if I had a vector? What if I had a vector and it was minus 5, 3? Okay, so 1 minute. Give me the answer in 1 minute. I would just, when I reach 6, I will stop. But yeah, do this from a fast. I give all a vector here, minus 5, 3. Find the angle between the vector and the x-axis. That's Ron, did you hear me?
Yeah.
Big up you. That's correct. That's correct. Easy, right? Real easy, right?
Yeah.
Right? Kadisha. Oh, I know sorry, you have your calculator out here. Right? Perseus. Who else, boy? Adetola. Jira, you there?
Yes, sir.
Joshua, let me know if you're there.
Yes, sir.
All right, Joshua, let me know if you're getting through with this. Joshua, you getting through this?
What V?
Yeah, finding the angle between this vector and the x-axis.
Yeah.
All right, so Joshua, um, what would x for this vector be, and what would y for that vector be?
What would X be?
And what would y be for this vector?
-5.
And y is
3.
nice. And the absolute value for y, well, that's positive, so I'm gonna change that. Just write back 3. And what's the absolute value for x?
V.
What's the absolute value for x? So x was minus 5. What's the absolute value of it? So all that means,
-5.
no, you have to use the positive value. So absolute value means positive. So you see how we have -5? We're gonna use positive 5. Yeah. So this is where you're gonna find tan inverse of. So any calculator, you're gonna find tan inverse at 3 over 5. Right? Real, I'm gonna know if you're okay with everything.
So I know what to do is just my calculator again. How am I writing 3/5?
All right, so 3 divided by 5, close bracket.
Oh, okay.
Because the background is fractions. Right? Perseus, don't forget to put wait, Perseus, that's wrong.
So that one minute, think I am absurd. I can't think my name.
Nah, you put the correct work in, I think you just put in the calculator wrong. Yeah, because you had the correct thing. Watch. When I press equal again, 30.96 and again 59.04. So check.
Again, big numbers, babe. So wrong with my calculator.
If your calculator is not in degrees mode,
Oh,
would
I'm not sure it's right.
So again, 0.54, what?
yeah, you get 0.54 if your calculator in radians mode.
Oh.
So now picture your calculator and I'll tell you how to convert it back to degrees.
So I just got it.
No, I calculated it. Like I fix it.
Where
I'm
you
gonna recalculate it now. I'm gonna do it over.
All right. So we understand how to find the angle. So now we can move on to magnitude. Right? You can move on to magnitude. And then we have to move on to unit vectors. All right. So I'm gonna move on, all right? Ria, did you get through?
Yes, I'll send you a picture.
Okay, cool. Right, so the last question or the last example really. So for anybody confused, you just find in tan inverse are positive numbers. That's all. You're not considering any negative numbers at all. Right? So for this example, it will be theta is equal to tan inverse of 3 all over 5. And you would get theta is equal to 30.96. Yeah. Right, so I hope everybody understands that. We good?
Yes, sir. So I think I realized my mistake when before I did this. I used to check for the negative numbers, not the positive.
Ah, yeah, can't use the negative numbers. The reason why is because you're considering the length. Like the whole point of this is you're making a triangle and you're looking for the lengths and you can't really have negative lengths. So can't look at the negative values. The negative just telling you the direction, right? But the length is positive. Right. So we're gonna move on now. Finding the magnitude of a vector. And to find the magnitude of a vector, we're going to use Pythagoras theorem. Does anybody remember Pythagoras theorem? Guys, are they real quiet, Does Ron remember Pythagoras theorem?
Yeah, I think so.
Okay. Well, here what does
Yeah,
Ron.
I remember.
All right. Well, here what does Ron. Give me a vector. Give me a vector.
9, 6.
And call a position vector, right? So we had to start from O, and where you want to end up at. O to what?
O to D.
All right. Okay, O to D. And you said it was 9, 6?
Yeah.
Okay. So you'll see what's gonna happen again. So just remind you, Pythagoras theorem goes a little something like this. It goes like a squared is equal to b squared plus c squared. So if I want to find for a, I'll have to do what does wrong. What's the opposite of squaring something?
Okay, the square root.
Right? So to find for a, it'll be the square root of b squared plus c squared. Now it's important to know that a is the hypotenuse. AKA the longest side in the triangle. So let's do that, but with a vector now. You'll see how it goes. You'll see how it pans out. All right, that's wrong. So we have 9, 6 here. Okay. So this is y. This is x. So tell me that's wrong. We're gonna start off. Actually, let me call Kadisha for this. Kadisha, you there? Kadisha. Can I hear Kadisha? Desron, tell me how to do this. So I'm starting off at the origin, and I'm gonna move how much spaces to the left or to the right. Tell me what to do.
You were 9 to the right.
Right?
And then 6 up.
Right. Right. So I'm gonna end up at this point. Yeah?
Yeah.
And I'll call this point what? So I just went
Call
from
it D. D.
D, right? And I would
Yeah.
connect it. So that is O to D. Notice it forms a what kind of triangle?
It forms a right angle triangle.
Right. And we know what this length is? And this
Yeah.
length? This is what's this
Yeah.
length here? What's this length here? This one over here.
I don't get 6.
That's 9.
So then I 9, 6 here.
Right? And we could use Pythagoras theorem because watch. Watch this, right? Um, watch. Pythagoras theorem says that a is equal to the square root of b squared plus c squared. Now a is the hypotenuse, and in this case, O to D would be the hypotenuse.
Yeah.
Yeah, and what would the other two sides be?
Other two sides is
Wait,
how about adjacent and opposite?
I would draw the proper diagram. Wait, draw the proper diagram. So this is D. Right, so tell me if you're following so far. Everything okay?
Yeah.
All right, so let's run. We have this mapped out. Okay. Now, this will be the hypotenuse, right?
Yeah.
Right, this would be the right angle. And when we're looking at Pythagoras theorem, we don't really care about the other two sides. Right, once we have the other two sides, that's the main thing. Great. So what would the dimension for this length be? What's the dimension for that length?
Are we 9?
Right? And what's the dimension for this length?
Are we 6?
6. Right. So tell me that's wrong. And according to Pythagoras theorem, which says that the hypotenuse would be equal to the square root of the other sides squared. Wouldn't that just be, wouldn't, wait, let me just call that. Wouldn't O to D just be equal to the square root of 9 squared plus 6 squared?
Yeah.
Yeah. And so that's how it is work. And a way to observe something. Isn't this just isn't that just the and the vertical component? Watch.
Yeah.
And this is the what component of the vector?
And the horizontal.
Nice. Right, so that's why I'm saying the formula. Right, that's what I'm saying. If you want to find the magnitude of the vector, it's just going to be equal to the square root of the x component squared plus the y component squared. Now in this formula, it doesn't matter if you choose positive or negative, you'll get the same answer. Right, so let me apply it for this question. So in this question, it would be O to D, and that would be equal to what does wrong?
O to D is
So where's the x component?
9 squared. 9 squared plus 6 squared.
Right, you're gonna end up with 81 plus 36, which is 117. Square root of 117. She get like 10 point something. Like 10.8. I think. You getting 10.8 something, so.
Yeah.
Okay, weird.
10.81. 10.82 you could say.
Let me check.
You're wrong this up.
Yeah, 10.82. All right, 10.82 units. So in other words, Ezron, that would be the length to the vector. That would be the distance. If I want to go from O to D straight up, that'll be 10.82 units.
Yeah.
Do you think you understand why if it's negative or positive, it don't matter in this formula?
Yeah.
Because what we doing to the x and y value?
The square root in it.
Now squaring it, watch, you're squaring it. So x squared plus y squared. If I square something,
I'm squaring it, yeah.
what would happen to
You
the
always get a positive, you always get positive.
Exactly. So it doesn't matter in this case, right? So this would be the y component. This is the y component, and this is the x component. Nice. Right, so we'll do some examples and then we will move on to something.
Yes, boy. Session nearly done now.
Yeah. Hey, Kadisha, look Tavon here. You know, just keep on asking, but look Tavon here. Don't know where Kadisha gone.
Technically been here the whole time, but yeah, it's half business.
Work have you occupied.
I really work on. I fighting with onion.
Say that again?
I say it's not really work. I in the kitchen fighting with onion.
Oh, you're cooking.
Yeah, boy.
I really smell something burning, you know. I really smell something burning.
You ain't smell nothing. You're like,
All right, so here what I want to let you copy this down, and I want you all to try this question. Find two-part question. Find the angle between the vector and the x-axis and find its magnitude. And I'm gonna give you two vectors. So first one vector O to R, that'll be -3, -20, right? And then O to F, -7, 2. Right, so I'm gonna give all you 6 minutes. Take seven. Right, so when you finish copying down the notes, I want you to try this question. So you're finding for theta and you're finding for the
For the
magnitude.
boat?
Yeah, you're finding for theta and the magnitude. Both. That's why I give all you 7 minutes. Right, so Ria, let me know if you're there. Long time I didn't hear from you, Ria. Ria, what's popping? You good?
Yes, I do.
I surprised you have so much energy, 4 hours on maths. You're bad. Right, so Ria, if we look at this formula, right, it says if you want to find the magnitude of any vector, it's just equal to the square root of the x component squared plus the y component squared. That easy?
Yeah.
Yeah, so whatever the x component is, you square it. Whatever the y component is, you square it. You add that, you find the square root. Yeah, answer one time.
Yeah.
Right. So you will do the questions, the 2 questions here.
So OR is equal to -3 or that's a 1?
That's -3.
Okay.
Oh, we
Thanks.
can fix that one. Let me just fix that. How to be at 3 now. Jada, let me know if you're there.
Yes, sir.
Okay. All right. I thought you sleep away there, Jada. I say you sleep away.
I'm on the verge of falling asleep.
Wait, boy, call
But
him a boring. She call him a boring, guys. Wait, boy. I joke.
no, I am
I
not.
know you,
I'm just
I,
too tired.
I know you don't be working and thing, and when you come home, you just teach. I mean, not teach. I'm mixing up my words. I'm tired too. But I know you just be working and you be busy whole day. So when you come home, you just be sleepy. I understand. You understand everything I'm doing so far?
So far, yes.
All right. Yeah, sure.
Positive.
Great. Great. Right, so 3 minutes remaining in. Hope you all getting through. Perseus, you getting through? I don't like the silence. The silence killing me. Silence killing me. Oh God. Are they gonna make me crash out? Silence is crazy. I hear any crickets chirping. Let's try to see you post up a status of somebody brain frying. That's how you feeling right now?
Um, nah.
Okay.
Yeah, good right now.
All right, so Carissa, I see you there. Nice, nice. So, all right, so Carissa, let me know if you're there. You hear me?
Yeah.
All right, so Carissa, you see how we have the absolute value of y over the absolute value of x?
Mm-hmm.
So, if you want, in the next line, you could just write positive 20 over 3. Yeah, because it means that you're taking the positive value of whatever you have. So, if you want, in the second line, you could just write 20 over 3, right?
Okay. So need to put the
Yeah,
yeah.
you don't need to put that. It understood because once you write a positive answer, it understood that you found the absolute value. The
Okay.
absolute value just be positive. Right? Let me just verify if your answer correct. Looks to be correct. Turn and do this off.
But I use my phone as the calculator right now because I don't have my calculator. So
That's okay, you got it correct. If you round it off to two decimal places, so you'll get 0.47, not 0.46, because it's 81.469. So 81.47 degrees.
okay.
Right? And what is that when you find the magnitude, is that negative 3 squared you have there?
Yeah. I
Okay.
was but I don't know if it was correct.
If you're using the negative values, put it in
Mhm.
brackets. So if you decide to use the negative values, I need to see this. So yeah. Right, so I need to see that. Right, but your answer is correct. Just for the final line, just put 20.22 units.
Yeah, right. So the units after.
And just put the brackets. If you're using negative numbers, you have to put them in brackets.
Okay.
And if you use negative number once, use it for both.
Everything.
Yeah. Don't just put negative 3, then put positive 20 now. If you do it like that,
Well, I wasn't sure if I was playing.
but the good thing about this formula is it doesn't matter if it's negative or positive. So you could have put 3 and 20 if you wanted, but
Okay, I didn't have to put the negative.
nah, you didn't have to put negative.
Okay.
All right, so the time is up, right? Send me what you have so far, everybody. All right, so Perseus, you got through?
I'm saying, man.
Okay, I see that Ron sent me something. Ria, I see that you sent me something. Okay, nice. Right. So let's do the question and let's see if you all were correct. So the first one, it's really simple. They want us to find the angle. So for the first one, theta would just be equal to tan inverse of 20 over 3. And that should give you 81.47 degrees, right? And to find the magnitude of that vector, that would just be square root of minus 3 squared plus minus 20 squared. And that would give you the square root of 409, which is 20.22 units. Right? Did you all get that for the first question?
Yes, sir.
Yeah.
Okay, nice. Perseus, what about you? Did you get that?
Yes, sir.
Okay, good. Let's work out the second one. So the angle for the second one will just be tan inverse of 2 over 7. 2 over 7. Right? And that would be 15.95 degrees. And the magnitude for that would be the square root of minus 7 squared plus 2 squared, which would be 7.28 units. So just verify if you got those answers. Did you all get those answers?
Yes, sir.
Okay, great.
Yes, sir.
So we good then. So we know how to handle angle and magnitude. Great. The next thing we have to move on to is position vectors. This has come very rarely, but it's easy marks once you know what you're doing. Trust. Right? So when you hear a unit, what comes to mind when you hear a unit? A unit. Unit, guys. What comes to mind when you hear unit?
Like one of something.
Same. I think the same thing, right? A unit. Right? So simply put, a unit vector has a magnitude. Somebody finish my sentence. It has a magnitude of what?
Of one.
Yep, has a magnitude of 1. Let me give you an example. Right, and when we are doing unit vectors, we typically do not use the column vector form. We typically use the unit vector form, right? So let me just do a crash course on the unit vector form. Okay, so Ria, let me know if you're hearing me.
Yes, sir.
Okay, so in the unit vector form, I'm going to use I and J. You'll see that frequently. So what was that? Is everything okay?
Yeah.
Okay, hearing a lot of noise. All right. So you're gonna see me using ing. What does that mean? What does that mean? So the magnitude of I is just simply 1 unit, right? And the magnitude of J is just 1 unit. Now, if you see I, just know that you're moving along the x-axis, and if you see J, that means you're moving along the y-axis. So I would correspond to a movement on the x-axis, and J would correspond to a movement on the y-axis.
Okay.
So check this. if I say that I move, let me give you an example, right? If I told you that, example, if I said O to A is equal to 1i plus 1j, what that means is I'm going to move 1 unit on the x-axis and 1 unit on the y-axis. So Ria, instead of writing 1, I'm going to write I, because that's what I stands for. Instead of writing 2 here, I'm going to write 2i. You understand?
Yeah.
So instead of writing 1, we're going to write I. I means 1 unit. So if I say 5i, that means I move 5 units along the x-axis to the right. That's all. That's all it means. Am I confusing you?
No.
Okay. So check this out. So if I say 1i plus 1j, this is literally all I'm talking about. So I'm moving 1 unit. I'm moving 1 unit to the right, followed by 1 unit up. Say with me.
Yes, sir.
Right? I would call this, what would I call this point?
P.
Nah, A.
A.
And by the vector was
Oh, right. I now see it. Right.
right. So that's essentially what a unit vector is. Right? So on the Cartesian plane, 1 unit on the x-axis would be I. 1 unit on the y-axis would be J. That's simply it. Right? That's all.
Oh, okay.
Right. Now I'll show you all an example of a unit vector just now. Right? But this is just a unit vector form. This is a unit vector form. Right. So you need to know that the position vectors one, 0 and 0, 1 are unit vectors along the x-axis. So let me just look at a quick example of what we're talking about, right? So check this. Okay, so Ria, if I have a vector of 1, 0, I could call that vector. We want to call that vector 1, 0. We want to call that vector.
Sorry, sir.
If I have a vector, give my name for a vector. O to what?
O to F.
Okay, O to F. If we say that vector, right? If we say that vector is 1i plus 0j, tell me what that would look like in terms of how it would move. So I would start off at the origin, and then I would move. How would I move?
You'll move 1 space to the right.
And then how much space is up?
None.
None. I see, understand what's going on there, right?
Yeah.
Great. If I were to find the magnitude for that, What do you think it would be?
Um,
So we just learned the magnitude formula. So the magnitude formula would just be the square root of the x value. The x value in this case is what?
1,
Right? So 1 squared, and the y value is
0. It would just be 1.
right. So that's an example of a unit vector. And I said that a unit vector has a magnitude of 1.
Yeah.
Yeah, so OF is an example of a unit vector. It's a unit vector. Right? And all right. And in this case, tell me what this would be, Ria. O to T. O to T would be what? See if you can figure out how I moved to reach that vector. And this is 1. How would I go from O to T?
Move 1 space up?
Right. Did we move left or right?
No.
So the I component would be what?
1?
0.
No.
'Cause
Oh.
we didn't
Oh,
move,
because we didn't move and we didn't move again. All right.
and the y component would be 1. 1. Right? And if I find the magnitude for that, I would also be 1, right?
Yeah.
Right. So the main formula you need to know for a unit vector, the main formula here, which is this. So if I want to find, right? Right. So if I want to find the unit vector, it's just simply the vector divided by the magnitude of the vector. And well, we know how to find the magnitude, so it shouldn't be hard. Right? I just want to do one question, and next class we will look at this in more detail. I just want to do one question. Right? All right. So let's run. Give me a vector. Given the vector O to what?
5, 10.
O to
O
what?
to P?
Given the vector O to P, right? And O to P, you say 5, 10, right?
Yeah.
So if how would I write that in unit vector form? In unit vector form. That'll be 5 what?
I'm writing 5 J.
5i. Because remember, if you say 5, 10, that means 5
Or
horizontal,
5 I, yes.
right? 5i plus 10j, right?
Yeah.
So given the vector OP is 5i plus 10j, find its unit vector in the same direction. Okay, great. So let's run. According to the formula, if I want to find the unit vector, right? So if I want to find the unit vector for O to P, I would just take, so let's run, you there?
Yeah.
Right, so let's run. I'm going to write the vector. So it's 5i plus 10j, okay, divided by the magnitude. how would I find the magnitude of that vector? Is it square root or what?
Equal to X and Y.
Right, so what is the x component here?
I come on 5.
5. So we're gonna write 5 squared plus,
Plus 10 squared.
right. So work that out and tell me what you get in the denominator. And I want you to leave it as a third. So that will be again like root 35. No, that would be 25 plus 100. That's 125.
Yeah.
All right. Which is the same thing as 5 root 5. All right. So I will explain this next class in more detail. Right, but there's one. If I wanted, I could split up the fractions. So I could say 5i all over 5 root 5. And what about for the other one? Plus 10 all over
Um,
5 root
5
5.
root 5.
Yep. Now the 5 and the 5 would cancel off. 5 into 5 is 1, 5 into 10 is 2. So you're going to end up with you're gonna end up with 1 over root 5i plus 2 over root 5j. Now, Ria, you're probably looking at this and saying, nah, how 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 the magnitude of that will be 1? And you're probably wondering, like, how? Because I'm telling you that this is a unit vector, and
Yes.
probably wondering, well, nah, that can't be 1. Well, let me see. So if I were to write that as a column vector by chance, how would I write it? How would I write it as a column vector, Ria? And this is the last thing I do for tonight. Yeah.
Um.
So what's the x and the y value from here?
So,
I promise it. I promise it not hard. Check the conversion, right? So I say an I is for the x-axis and j is for the y-axis.
yes, I know, but it have like so many numbers.
So I'll help you, right? So the first one, 1 over root 5, and what would the y value be?
Oh, the 2 over root 5.
If I want to find the magnitude of that, it would be the square root of, open bracket, with the x value. So Ria, I just making sure we're correct, right? Because I told you that a unit vector has a magnitude of 1. So if we just find a unit vector, then when we find the magnitude is supposed to be 1. So Ria, square root of x squared plus y squared. What is the x value here?
The 1 over root 5.
So I'm gonna square that, and I'm gonna add it to what squared?
2 over root 5.
You would be impressed if we get 1, right? Out of our madness.
Yes.
Open square root. Let me see if it will work out. 1 over root 5 squared plus 2 over root 5. Fingers crossed, Ray. I think you're gonna work out.
I mean, yeah, it probably will work out, but damn.
Whoa, what's that? What's that?
Wow.
Madness.
Wow.
I
Oh.
sense magic.
Next class I will go into the concept a bit more. But that's crazy, right, Ria? So yeah.
Yeah, so you need to tell us how that happened.
I could go into over very briefly now.
No, no, like I understand like the process and everything is all the numbers turn into one.
Okay, watch. So I can show you it fast. Like 1 over root 5. So 1 over root 5 squared plus 2 over root 5 squared. Okay, so the square number, and it means it multiplied by itself.
Yeah.
So this will be 1 over root 5 multiplied by
1 over root 5.
1 by 1 is.
1.
Now, when you're multiplying two square roots, okay, so you see how we have root 5 or root 5?
Yeah.
Wouldn't that just be root 5 squared? Because
Yeah.
you're multiplying root 5 by itself, right? So what's going to happen is the square and the square root going to cancel off, so that'll just be 1 over 5,
Oh.
right?
Oh.
Right? Let's work out the 2 over root 5 squared. So that would mean 2 over root 5 multiplied by 2 over root 5. What's 2 by 2?
4.
What's root 5 or root 5?
5.
So we're gonna end up with, so this whole thing here, that just means 1 over 5. And this whole thing here just means 4 over 5. So what is 1 over 5 plus 4 over 5? One over 5 plus 4 over 5. What's that?
Oh, 5 over 5.
It
Right.
is 1.
Wow.
Yeah. Badness. Right? So let me just tell you what we're gonna do next class one time. So next class, I want to just re-explain this because I know we're tired. Objectives for next class. I want to revisit position. Yeah. Revisit unit vectors. I want to talk about, let's see. I want to take some time to talk about resultant vectors. I want to talk about linear vectors. Yeah, and that'll be it for vectors, really. We can do pass paper question. So next class, we could possibly finish vectors. The whole of vectors. Possibly. It's very possible. Right? So yeah, guys, I hope all you have a good night. Thank you for coming to class today. I will see you guys next time. Later, everybody.
Here.
Yeah.
Good night.
Good night.
Good night, sir.
Good night. Bye-bye.